So hello dear students. Today we will solve one problem, uh, and this problem is based on chapter heat chapter, that is from class 10th, and this problem is from ICSE board 2025 problem. And today we will solve some problems, and these all problems will be based on chapter number 10, that is heat. So first problem is like this. First problem, just see. 30 gram of ice at 0 degrees Celsius is used to bring down the temperature of a certain mass of water at 70 degrees Celsius to 20 degrees Celsius. Find the mass of water. You have specific heat capacity of water is given, and it is 4.2 joule per gram per degree Celsius. And specific latent heat of ice is given, and it is 336 joule per gram. So we'll proceed for the solution. Here you have mass of ice given, and it is mass of ice, mass of ice you have given, and it is 30 gram, 30 gram, and heat absorbed, heat absorbed, absorbed to be converted, to be converted, to be converted into water, into water, to be converted into water at 0 degrees Celsius. Now, students, in this problem, we have to apply the principle of calorimetry. So here what we will do, we will just calculate heat absorbed and heat lost. Okay. And these two will be equal to each other according to the principle of calorimetry. Then we can calculate from there the mass of water. Okay. Now here at, at 0 degrees Celsius, ice will absorb heat, and it will convert to water at 0 degrees Celsius. So here it will be, as you all know, heat absorbed is given by Q is equal to mass m1 into latent heat of ice. So here Q is equal to mass m1 is 30 gram into, and you have specific latent high heat of ice is given, and it is 336 joule per gram. Here it is 336 joule per gram. So here it will be 336 joule per gram. Actually, students, if you are doing any calculation in uh, physics, if you are doing any numerical problem in physics, so just write down the units. Okay, so there will be no confusion in units, and unit is coming correct, then it's obvious that you are going in the right path. So here Q will be equal to 30 into 36, and here we are left with joule. And if you will multiply this 336 into 30, it will come out to be 10080 joule. This is heat absorbed by a ice when the ice will convert into water at 0 degrees Celsius. Next, in the problem, if you will read, it is given 30 gram of ice at 0 degrees Celsius is used to bring down the temperature of certain mass of water at 70 degrees Celsius to 20 degrees Celsius. Now, students, You have water at 0 degrees Celsius. It will absorb heat to convert into 20 degrees Celsius. So here, heat absorbed, heat absorbed, heat absorbed, heat absorbed, rise of temperature, rise of temperature, rise of temperature, rise of temperature from 0 degrees Celsius to 20 degrees Celsius. So here it will become Q is equal to M1 into C into delta T, where C is specific heat capacity of water and mass will remain same. जो आइस का मास होगा that will be the mass of water. So here Q is equal to 30 gram into specific heat capacity of water is given and it is 4.2 joule per gram per Celsius into, and here if you will see, the change in temperature is 20 degrees Celsius, 0 to 20, and here if you will calculate this, it will come out to be 30 into 4.2 into 20 into joule. The unit will be joule because heat is energy. So here, if you will calculate this, it will come out to be 30 into 20. It will be 600 into 4.2 joule. This. And now, total heat energy absorbed will become total heat absorbed. Here, it will become Q is equal to 10080 plus 600 into 4.2 joule. Is this clear, students? So this. So now next, we have calculated total heat absorbed. Now we have to calculate total heat lost. Okay. Now, here, if you will see the problem, 30 gram of ice at 0 degrees Celsius is used to bring down the temperature of certain mass of water from 70 degrees Celsius to 20 degrees Celsius. Here, if the temperature of water fall down from 70 degrees Celsius to 20 degrees Celsius, so there will be heat lost by water. So we will calculate the heat lost by water. So here, heat loss, heat lost, heat lost by water at 70 degrees Celsius, 70 degrees Celsius to come down to come down to come down to 20 degrees Celsius. So here it will become Q is equal to M2 into C into delta T. Okay. And this is the M2 is the mass of water. So here Q is equal to M2 into specific heat capacity of water is given. It is 4.2 joule per gram per degree Celsius into change in temperature, and here change in temperature is 50 degrees Celsius, 70 minus 20. So here, if you will simplify this, it will become M2 into 4.2 into 50 joule. So now, here we have calculated total heat absorbed and total heat lost according to principle of calorimetry from the principle of from the principle of from the principle of principle of calorimetry calorimetry heat total heat absorbed is equal to total heat lost. Total heat lost. So here total heat absorbed is 10080 plus 2520, which is equal to M2 into 210. And if you will calculate, M2 is equal to 12600 upon 210. 0 cancel and it will come out to be 60 gram. So here M2 is 60 gram. And here we have to find the mass of water M2 and it is coming out to be 60 gram. So the final answer is 60 gram. Now come to second part of the problem. What is second part? Just see. Here the problem is a certain amount of heat will warm 1 gram of water, 1 gram of material X by 10 degrees Celsius and 1 gram of material Y by 40 degrees Celsius. Now in the problem, they are asking which material has higher heat capacity. So this is a very simple problem, little bit tricky one. Here we will just apply the concept of specific heat capacity and nothing else. And we all know what is specific heat capacity. Now, specific heat capacity of a substance uh, is defined as the heat capacity per unit mass of a body of that substance, and it is just given by a formula. If C is equal to C dash upon mass of the body, that is small m, where C dash is heat capacity of a body C dash, and C is specific heat capacity. So here it will become C is equal to, we know heat capacity, it is equal to Q upon delta T into M. So here we will apply this formula, that is the formula of specific heat capacity, to solve our problem number second. So here just to see, I am proceeding for the solution here. Now here a certain amount of heat is there, which is warming 1 gram of material X by 10 degree Celsius. So here C is equal to Q upon mass of X particle. I am taking it by mx into delta T, which is change in temperature. So here Q upon mass is 1 gram and change in temperature is 10 degrees Celsius. So here it will become Q by 10 per gram, and per degree Celsius. This will be the unit of specific heat capacity, that is per gram per degree Celsius. So now we will see for material Y. Similarly, we will calculate specific heat capacity for material Y. And here I am denoting it by T dash. C dash is equal to Q upon My into delta T. So here it will become Q. My is again 1 gram and temperature is 40 degrees Celsius. Change in temperature is 40 degrees Celsius. The unit will be again per gram per degree. Here, if you will divide C by T dash, then it will become C is Q by 10, Q by 10 upon Q upon 40. So it will become 40 by 10 and it will become 4. So here C will become 4 C dash. So here C will become 4 C dash. And if you will see here, C was specific heat capacity for material X and C dash was specific heat capacity for material Y. And as you can see, the specific heat capacity of material X is equal to 4 times of specific heat capacity for material Y. So here material X has higher heat capacity. So material X has higher heat capacity. Heat capacity. So this was the solution of this problem. So material X has higher heat capacity. So now we will see next problem. It is the next problem. Let's see. Next is now. Which material X or Y would you select to make a calorimeter? आप सिंपली देखो, हम कैलोरीमीटर बनाने के लिए वही मटेरियल सेलेक्ट करते हैं जिसका लो हीट कैपेसिटी होता है. तो यहाँ पे लो हीट कैपेसिटी किस मटेरियल का आ रहा था? इट वॉज फॉर मटेरियल वाई. It was for material Y. So here we will choose material Y to make a calorimeter. So now next is they are asking the statement problem, that is true or false. The problem is, you see, the specific heat capacity of a substance remains the same when it changes its state from solid to liquid. Now you have to state true or false. So students, a specific heat capacity of a substance does not remain same when it changes from one state to another state. Actually, the specific heat capacity is this. This is phase independent. This is phase independent. Phase independent. So this statement is false. Okay. It will not remain same when it changes from one state to another state. So this will be false. So this was the one whole problem based on chapter number 10, that is heat. Now we'll solve another problem. Let me upload the problem. Students, this is a very basic problem, as you can see. Problem is like this. we have to calculate the amount of heat absorbed by 200 gram of paraffin wax to melt completely at its melting point, and you have a specific heat, latent heat of fusion of paraffin wax is given, and it is 146 joule per gram. So here, as we all know, uh, specific latent heat is given by this formula. It is L is equal to Q by M. So here we have to calculate heat. So Q is equal to ml. So here it will become Q is equal to mass is given 200 gram, and you have specific latent heat of fusion of paraffin wax is given. It is 146 joule per gram. So here, if you will multiply this, uh, 2 into 146, it is 292, and 292 into 100, it will become 29200 joule. So this amount of heat energy is required for paraffin wax to melt completely at its melting point. So the answer is 29200 joule. Now we'll solve one more problem, and this is the last problem of today's class. Let me upload the problem of this. This problem was in MCQ form. Yes. The problem is like this. There is a metal piece of mass 5 gram and has thermal heat capacity, that is this 2.5 joule per Kelvin. And if the mass of metal is tripled, then you have to calculate its specific heat capacity. Here in this problem, you have to calculate its specific heat capacity. So here, students, actually specific heat capacity, specific heat capacity, specific heat capacity, it does not depend on mass. It does not depend on mass. It does not depend on mass. So here, specific heat capacity is given by specific heat capacity is given by, it is a specific heat capacity, it is given by thermal heat capacity upon mass m, So here they have given thermal heat capacity, it is 2.5 joule per Kelvin, and you have mass, they have given 5 gram, and specific heat capacity does not depend on mass, so mass will remain same. And if you will calculate this, it will come out to be 0.5 joule per gram per Kelvin. So this is the specific heat capacity. And if you will see the options, option D will be the correct answer. So this is the correct answer. So this was the solution from my side. If you like my problem solving technique, then please like, share, and subscribe my YouTube channel. That's all. Thank you.